In the previous episode, we did some repairs and modifications to the 719cc Kubota diesel-powered Saturn, and to our delight we achieved a new top speed of 71 miles per hour, and we shaved 25 seconds off the 0 to 55 mile per hour acceleration test. To top it all off, the fuel economy jumped from 56 to 59 miles to the gallon. Overall, not a bad day at the office, but we did encounter some problems. The issue we were plagued with was the exhaust gas temperature had to be closely monitored because if unchecked, it would have certainly destroyed the engine. Today we're going to attempt to correct the exhaust gas temperature issue by installing a turbocharger. Now it's important to remember we're dealing with a diesel engine and not a gasoline engine. When we modified the fuel rack adjustment on the injector pump for more fuel and more power, well, that translates to a hotter exhaust on a diesel engine. So in our case, the turbocharger will force additional air into the combustion chamber, and that'll mix with the extra fuel, resulting in, believe it or not, a leaner burn, thus reducing the exhaust gas temperatures. I know it's crazy, but this is how it works on a diesel. Anyway, as we move forward, take into consideration that we're dealing with a relatively small displacement diesel engine, and our main goal is to boost the power output while not damaging the engine at the same time. The turbocharger we'll be using is an RHB31, otherwise known as the $100 eBay turbo. Well, good luck finding one for $100. However, they can still be found for less than $1.50 if you do a bit of searching. Anyway, the RHB31 turbocharger is ridiculously small and was originally used on the Suzuki Alto or Daihatsu Mira. Of course, both of these cars are K-Class automobiles with very small displacement engines ranging from 550 to 660 cc's and were never imported for road use in the United States. Now, due to the language barrier, that's the best my research could yield. However, the bottom line is the RHB31 was made for a small displacement engine, and due to the popularity of these little turbos, there are spare parts and accessories available to make installation a lot easier. Now, at the end of the previous episode, I gave the audience a sneak peek at the turbo on the Kubota engine, and I got a lot of comments of how nice it looked. Actually, that would have been nice. Instead, I got comments indicating that I installed the turbo wrong. Uh-oh, Jimbo screwed up. Let's take a look at some cartoons for clarity. So basically I had the turbo mounted to the engine like this, and this is forbidden according to the turbo gurus. You see, with the turbo mounted like this, the axle for the impellers goes in this direction, and the oil feed goes in this direction. Well, this will cause oil to seep into the compressor or turbine section, which is not good. The only way a turbo can be mounted to an engine is with the axle going in this direction, and the oil feed going in this direction. This is one of those situations where arguing will not change the outcome, and unfortunately this turbo is mounted incorrectly and we'll have to change it. So clearly I don't know what I'm doing when it comes to some of the basics of installing a turbocharger, and this is after I did a lot of research. But keep in mind, when you do something new, you don't know what you don't know. So even though I have an extensive background in automotive stuff, and I've worked on turbos before, I didn't know the first rule in the Turbo Club, but my audience did. Actually, I was quite surprised how many turbo people are in the audience. Turbo people are a special breed, and when they sneeze it sounds like this. Anyway, I'm thankful for the heads up, even though it required massive changes and I had to re-edit this entire video. Let's get going on this turbo installation. The sooner we finish, the sooner we can take the car out for a ride. So previously I mentioned the RHB31 is a popular low-cost turbo, and the accessory parts are readily available also at low cost. Here we have a flange kit that I picked up, and it has all the necessary parts we'll need. Actually, some of this stuff we won't be using, like the drain flange and the intake and charge pipe flanges. So the first flange we'll need to deal with is the one that goes to the exhaust input side of the turbo, and that goes here in case you're wondering. Now this flange is probably okay for most applications, but on this build the hole in the center is too small for the pipe I intend to use. If I recall correctly, the hole in this flange is about 1 inch or 25 millimeters, and the pipe we're going to use is 1.5 or 38 millimeters. So we're going to have to enlarge this hole somehow. I reckon we could use a stepped drill bit, but finding one that stops at 1.5 inches, well, those are expensive and actually hard to find. Anyway, most stepped drill bits go up to 1 3/8 inches, so for this modification, we'll have to use the lathe to bore out the center of this flange. This little lathe has saved my bacon hundreds of times, and it was well worth the investment. The flange was bored out to more or less an interference fit with the pipe, and this is not necessary, but it makes it easier to hold stuff together when doing a mock-up. And all it takes is a few taps with a hammer to get the flange to fit the pipe. Now on this side of the flange, I undercut it slightly, and that's so we can weld the pipe to the flange on the inside. The weld will certainly mess up the flat surface, so afterwards we'll have to clean it up with the belt sander. Anyway, that more or less preps the flange for the turbo side. Let's take a look at the flange on the engine side. So this flange was custom made because you can't buy an exhaust flange for a Kubota engine. Believe it or not, this flange was made on the lathe because for me that was the simplest way to build a precision part. Now when I made this flange, I knew I was going to have to make another one when we installed the turbo, so I 3D printed a flange making tool thingy. So this thing is sort of an all-in-one template for making Kubota exhaust flanges. Let me show you how it works. First we have to find a good center on this 1/4 inch thick steel plate. Once we have a good center, then we drill a 2mm hole in the steel with the drill press. After that, we bolt the template to the steel with a 2mm screw, and now we can center punch the 4 bolt holes that will line up with the exhaust manifold on the Kubota engine. Now this thing here is for drawing the circular outline of the flange, and now we draw the outline like so. Now this part sucks. Using an angle grinder, I rough cut the circle out of the steel plate. Now these cuts don't have to be perfect because we'll be using the lathe to finish the circle. Next I enlarge the center hole to 3/8 of an inch. Eventually we'll need to make the hole 1.5 inches, but there's a method to my madness. Alrighty, looks like the 3/8 bolt fits nice and snug. Now fast forward a minute and we have the bolt tightened up. Now for this operation, I'm using grade 8 hardware to avoid possibly bending stuff when I turn this on the lathe. And now we can trim this chunk of steel into a perfect circle. Well, we're almost done. I have the flange bolt holes drilled out, and next we need to bore out the center so our 1.5 inch pipe will fit. The purpose of making this flange round was so we could center it on the lathe so we could bore out the larger hole. And that's nearly a perfect flange. Everything is precisely centered. Now just like the previous flange, this one's bored for an interference fit, so getting the pipe to slip onto the flange requires a few taps with a hammer. Now I'm sure there's other ways to make this flange, but keep in mind the only tool I have to cut an 1.5 inch hole is the lathe. But I reckon a file would work as well, but that would take forever. Now the last bit we need to do is trim the flange so it's square. For that we'll use the template again and draw the cut lines. For this operation, we'll use the template face down so it engages with all the holes, and that will allow me to draw the cut lines so everything's still centered. Now all we have to do is slice off the extra material with the angle grinder. That's 1 down, 3 more to go. This came out pretty good. Now, the straight pipe we're using is just to verify fitment. The actual pipe we'll use has a 45-degree bend in it, so the turbo will clear some of the stuff under the hood of the Saturn. Alright, fast forward a bit, and this is the finished assembly. On the inside of the flange, the pipe was fully welded, and on the outside we put a few beads for extra strength. Now this weld here is so the turbo could be repositioned to allow the drain to go in the right direction. This was done to fix the mistake I originally made. Now some of these welds are pretty ugly, and I'm okay with that because I made this. However, I think something like this would look a lot better if it were TIG welded, and perhaps I need to consider investing in one. So now that we have the connection from the exhaust manifold to the turbo sorted out, let's take a look at how we're going to supply oil to this little guy. This hole is for feeding the turbo its oil supply, and it looks like the supply line should also have a banjo fitting due to the limited space. Well, after some searching on the internet, I found an oil feed kit made specifically for the RHB31 turbo. Let's check it out. Kin you wanna? Or something like that. Oh, it's got a picture of Satan. So I looked this up, and Kin you wanna means angry demon. So I reckon that ain't Satan, but it's a demon, an angry demon to be more precise. But if you look closely, this guy is smiling, so it can't be that angry. Anyway, this kit with the angry demon or happy demon has the necessary parts to supply our turbo with happy demon oil. Now, it would certainly be tempting to get a cheapo universal kit from the jungle site, but I already did that, and nothing from those kits will fit this turbo, so that was a waste of money. Now, this kit costs $39 on the Jungle site, and it's made specifically for the RHB31 turbo, so obviously this is the way to go. Let's check it out. Right away, we can see it has a very nice braided supply line. Meh, let's take a look at the important bits. Now that's what I'm talking about. Here's the banjo fitting we'll need, and it even comes with the necessary copper washers. Alright, now look directly inside this banjo bolt. This small hole is the restrictor, and that slows down the flow of oil. As I understand it, it helps prevent too much oil from entering the turbo while still maintaining oil pressure. You see, if too much oil flows into the turbo, there's a risk of some of it getting past the seals. Let me assemble this and verify the banjo bolt will thread into the turbo. Yeah, that seems fine. Now, we're just loosely assembling stuff right now, and we'll certainly tighten stuff up later. Okay, it looks like this is a 2AN fitting. Let's see if the braided hose fits. So far so good. Let's check the other end, and yeah, this is another 2AN fitting. And it looks like this thingy here has the matching male fitting. Now over on this side, we have a 1/8 inch NPT fitting. So the way this oil feed kit works is, you remove the oil pressure sending unit on the engine and screw this NPT threaded part into the engine block. And just like that, we've tapped into the oil supply line. That way we can divert some of the oil to the turbo. It's pretty neat. Now when we install this on the engine, we'll have to remove this plug and then screw in the oil pressure sending unit like so. Overall, everything seems to fit fine, and it's just a matter of screwing everything together when we install the turbo. Let's take a look at the drain side of the turbo. Like I mentioned before, I originally purchased a universal oil feed and drain kit from the Jungle site. None of the oil feed parts fit this turbo, but I was able to salvage some of the drain parts. Let's go back in time to Season 2, Episode 26, when we first installed this engine in the car. So before we installed the little diesel engine in the Saturn, we modified the oil sump for a turbo drain. Well, that was because we knew we would eventually install a turbocharger. Anyway, the drain system on the engine's been capped, and all we need to do now is remove the cap and install the rest of the drain plumbing. This drain system has a 10AN fitting on the sump side, and we also have parts to do a 10AN on the turbo side, but using 10AN parts on the turbo side presents a lot of problems as far as fitment goes. So, for the drain connection, we're going to use the parts supplied with the Angry Demon kit because it's much easier to deal with. So this drain just bolts up to the turbo without any fuss, and of course we'll install the gasket eventually. If you plan on fooling with one of these RHB31 turbos, this Angry Demon oil feed kit is pretty much the only low-cost option, and everything seems to fit like it should. Now this will upset some people, but we're not going to go crazy with the boost. I don't recall exactly, but this acculator is set up to open the wastegate at about 14 or 15 psi of boost, and it's hard to say whether this turbo will actually make that amount of boost, but just to be on the safe side, we're going to get rid of this acculator and install an adjustable one. Our plan is to initially set the boost to about 7 psi or 0.5 bar. Let's take a look at the adjustable wastegate acculator that we're going to use. And here's the part number for the folks playing at home. Now this kit was pricey, and I think it cost me about $130. I reckon we need to open up the box and empty all the junk out. So this is the wastegate thingy, and it has a calibrated spring inside set to whatever as far as boost goes. We're going to replace the spring with a 7 psi spring. Now replacing the spring requires that the acculator be opened up, so let's fast forward a bit. So this is the thingy all apart, and there's more or less just a few parts inside of it. This spring is what sets the boost pressure, and we'll be replacing it with a lower pressure spring. Like I mentioned earlier, we're going to start off by setting the boost to about 7 psi and see how the engine reacts to that. Putting this wastegate acculator back together, well, that takes a while, so let's just fade to black and it will be magically reassembled. That's better. Okay, so we have the lower pressure spring installed, and we went ahead and loosely assembled the rod and the rod end. Let's figure out a way to install this thing. Now this is the old wastegate acculator, and we're going to want to salvage the mounting bracket. It looks like we can just drill out these spot welds and separate the bracket from the acculator. Fast forward a bit, and yeah, it got a little violent, but I was able to separate the parts. Let's see how the new parts fit. Meh, it looks like we're going to have some problems getting the acculator to fit. Off camera, I fabricated a chunk of steel that we can weld onto the bracket and make a larger mounting base, and that should solve our problem. However, now we have a new problem. I'm not sure what they plated this bracket with, but more than likely, it will release toxic gases when it gets welded. So before we can weld the bracket, it'll get soaked in muriatic acid, and that will dissolve the gold-colored plating. Now, vinegar will also work, but it takes a bit longer. Muriatic acid has a pH of around 2, and that's about the same as stomach acid. Or, if you want to get gross, the strength of this stuff is about the same as vomit. Of course, that's no reason to be careless around acids. Now, keep in mind muriatic acid can have strong fumes and can cause respiratory damage. Anyway, being it's winter here in Kansas, the cold acid took a lot longer to dissolve the plating, but after about 45 minutes, it eventually got most of it off. A quick rinse in water washes away the majority of the acid, and I'll clean the rest off with warm water and some soap. Fast forward a minute, and the bracket's all cleaned up, although there's still a tiny bit of plating on the backside. This new mounting plate needs to be welded on the bracket like this, and we're going to need to keep both of these holes centered. So, I made a temporary bushing that will hold everything in position while we weld these parts together. After we weld these parts together, we can drill these holes completely through. Now it looks like on this one, it'll be on the edge of the weld area, so we're going to have to do some blacksmithing. For some reason, I love to hammer on red hot steel. It's so satisfying to bend metal with fire. And now we weld. Well, here it is, all nice and pretty. The backside, well, that ain't so nice, but who's going to see that? The acculator seems to fit perfectly, but we still have a problem and it looks like we need to make some spacers. Let me assemble this so we can figure out how long the spacers need to be. Looks like about an inch or 25 millimeters would do it. Well, back to the lathe. For the spacers, we're going to use 6061 aluminum. I like to use 6061 for pretty much everything because it's a decent alloy and it machines nice. Plus it's cheap. I bought this lathe brand new from Smithy in Ann Arbor, Michigan about 20 years ago. At the time I didn't even know how to use a lathe, but I've gotten a little bit better. Alright, that should just about do it. Let's see how all this stuff fits together. So these are obviously the spacers, and I pretty much eyeballed them. Let's see how close they are to 25 millimeter. Not too bad. Anyway, they have a 6 millimeter thread all the way through. Now I like to make fun of the metric system because, well, I'm American. But the truth is I do everything in metric as far as fabrication goes. Now as far as hardware goes, I mix and match stuff. Sometimes I use metric, but most of the time I use SAE fasteners. Today we're using metric though. Well, let's put this together and fit it to the turbo. That's pretty much it. I still have to adjust the wastegate acculator preload, and all that means is there should be some tension on the acculator rod to firmly hold the wastegate closed. I reckon about 2 millimeter or 1/10 of an inch preload should be enough. I think at this point we can start fitting these parts to the Kubota engine. In case you missed the previous episodes, this is the exhaust gas temperature probe. Now over here we have the oil feed for the turbo tapped into the engine block, and all we have to do is connect the braided stainless steel line from here to the banjo fitting on the turbo. Alright, the turbo's ready to install, the wastegate preload has been set, and all the bolts have been tightened. And I even put proper hose clamps on the boost reference hose. It's go time! It took some doing, but this dilapidated Saturn with a 3-cylinder engine from an industrial compressor now has a turbocharger. And this time around, we put the oil drain in the correct location. Now I'm itching to take the car out for a ride, and I'm sure you folks want to see that as well, but we still have a few more things to do. The last thing we need to fabricate is a way to connect the turbo to the intake manifold, then we need to make a thingy for the air filter. Now for both of these items, we're going to make them from 2-inch exhaust pipe and some huge washers from the hardware store. Trust me, it'll be fine. Both the input and the output of the turbo need to be scaled up so we can use off-the-shelf plumbing from this point forward. So the plan is to convert everything to standard 2-inch turbo plumbing, and then we won't have to deal with these one-of-a-kind flanges that were supplied with the flange kit. Anyway, that's the plan. All we have to do now is weld this stuff and we're finished. So for the output of the turbo, we have this freshly built 2-inch sleeve. Now, this is probably way too big, and we'll have to use a reducer because the intake manifold on this engine is only 1.5 inches. For the input side of the turbo, or basically the air filter side, we have another oversized sleeve. Here's where it gets complicated. The outside diameter of the sleeve will fit the air filter perfectly. For the inside of the sleeve, I 3D printed an insert that we'll use for the crankcase ventilation system. The rocker cover on this engine has all the necessary baffles and whatnot, and all I'm doing with this crankcase ventilation modification is changing it from a direct line to the intake manifold to the input side of the turbo. The 3D printed insert may need some future modifications, but for now it should work. So what's next? Oh yeah, I almost forgot, we have to connect the turbo to the intake manifold. Oh, we do have an intercooler for this project, and I'm sure it's going to need it. However, I want to do our preliminary testing without the intercooler. Once we sort everything out, then we'll install the intercooler and see how much of a difference it makes. If you're not subscribed already, you may want to consider subscribing now, so you don't miss any future episodes. Currently, this car accelerates like a fully loaded garbage truck, and the plan is to improve the performance to right around here. I think we may have a shot with this turbo upgrade. Before we make the connection between the turbo and the intake manifold, I reckon it's a good time to start the engine and make sure the turbo actually spins. Various sources on the internet indicate the engine should idle for about 20 minutes when installing a brand new turbo. I don't know how true that is, but it can't hurt. Turbochargers generally only make boost when you put the engine under a load. However, we should get some air from the turbo if we rev the engine. Yup, it's spinning, and that's a relief. Well, I reckon it's time to install the charge pipes. So far so good. We have the engine warmed up, we have the charge pipe installed, and we have a boost gauge on the dashboard. You know what comes next, don't you? So we have the exhaust gas temperature gauge and the boost gauge. Now, the lighting sucks and you probably won't be able to see any of these gauges, but that ain't going to stop me from taking the car for a ride. The purpose of this test drive is to verify we have boost and to see if the exhaust gas temperatures stay below 1000 degrees Fahrenheit. Now, the fuel rack is still adjusted to 33 millimeters from the last time we drove the car. This rack adjustment gave us decent power, and if we were careful, we could manage the exhaust gas temperatures. But if we weren't careful, the temperatures could exceed 1050 degrees. Unfortunately, you folks can't see the gauges, but we are making boost. The gauge is showing 5 psi, which is less than I expected, but we have room for adjustments if the turbo is capable of that. The exhaust gas temperature gauge is indicating the temperatures have stabilized and they're running between 850 and 950 degrees Fahrenheit. And that's with my foot all the way to the floor. This is all very good news. Okay, so I set up another camera so you guys can see the boost gauge. Unfortunately, the exhaust gas temperature gauge doesn't show on the video due to the lighting, but for now the boost gauge should be enough. Today we're just verifying everything works and not necessarily trying to beat our previous acceleration time. As a matter of fact, when we did our epic 40-second 0 to 55 mph acceleration run, the fuel rack was adjusted to 32 millimeters, and right now it's adjusted to 33 millimeters. That 1 millimeter makes all the difference. I reckon we should see some decent results once we tune the system to take advantage of the turbo. I have to say that was a very successful first drive with the turbocharger. Let's take a look under the hood and make sure everything is still connected. Wow, the induction pipe's hot. I mean, it's really hot. Eventually, when we install the intercooler, it'll be interesting to see what kind of a difference that makes. The rest of the engine looks fine. I'm not seeing anything scary like oil or exhaust leaks, so we're going to call this good. Well, let's do a quick summary. In the last few episodes, we experimented with the settings on the fuel rack in the injector pump. Obviously, the purpose of these experiments was to get more power from this little diesel engine. Sure enough, adding more fuel makes more power. However, the power wasn't really usable long term because the extra fuel caused the exhaust gas temperatures to increase. So adding the turbocharger allows us to force more air into the engine so we can take advantage of the additional fuel. It's interesting how much power we got with just the fuel alone. And right now the turbo doesn't seem to do much except basically keeps the exhaust at a reasonable temperature. Probably not what you expected. So what's next? Well, we have some tuning to do, a little bit here, a little bit there, and we'll find out how much power we can really make. Then we'll add the intercooler, which this engine desperately needs, and see how much that helps. Of course, at some point we need to look at modifying the injector pump timing. As far as that goes, we have a little bit of wiggle room, but not much. Anyway, it'll be interesting to see how much that helps. So as you can see, we still have a lot more to do. Once we sort everything out, then we need to reduce the weight of the car, and unfortunately that may involve some cutting. If you're new to the channel and this sort of thing interests you, well, the good news is there are 8 additional episodes that cover just about everything you need to know about this project. So check it out. I look forward to seeing you folks next time. Until then.